Hello dear students, this is D5.5. No, for example, we have part A, the distance from node and antinode. Okay, so node and antinode, the two waves of the amplitude 4 centimeter and frequency of 14 hertz are moving in opposite direction with velocity 5.6. Okay, so in this question we have to find how far apart would we have the antinode to be formed from the node on either side of them. So in this question, so first I write the given information. So given information is amplitude is 4.0 centimeter, frequency is 14 hertz, and the wave speed is 5.6 meter per second inverse. And what we have to find in this question, we have to find the distance between antinode and the node. Distance between antinode and node. Antinode and node, question mark. Okay, so in order to find the distance of, we must find the wavelength. First one, this is the wavelength, complete wavelength. This distance is complete wavelength lambda. So first we have to find the wavelength, but we know that we have the frequency, the wavelength. So lambda is equal to v over f. V is equal to f lambda, and lambda is equal to v over f. V is 5.6 meter per second and the frequency is 14 hertz. So we get the wavelength, that is equal to 0.40 meter. Okay, now we have to find the we have the value wavelength. So wavelength is actually from this point to the highest point. This is the complete length of a wave. Okay, so the wavelength is, we know that this 1 2 3 4, you know that this is this point is actually node, this point is actually antinode, this point is again node, this point is actually antinode, antinode here, and then again we have a node. So we must need to find the distance between node and antinode, or antinode to node, you can say the same distance. Okay, so antinode to node. So if I say that we want to find distance between node and antinode, and this distance is, you know that this node and antinode is actually the one quarter of this complete wavelength, one quarter, one fourth of this. So you can say that, so the distance between antinode and node is lambda by 4. This is a complete wavelength, so this is the lambda over 4. 1 over 4 lambda mean one quarter of the wavelength. So lambda is 0.40 meter, we divide with the 4, we get 0.10 meter. So this is the distance between node and antinode, or antinode to node. Okay, now for the part B, what must be the minimum length of the string? So minimum length is when we have the single loop. Okay, this single loop, so we need to find this length, minimum length, in order to find the one loop or first harmonic. Okay, in order to find this, as we know that we already know that this distance between complete wave, that is lambda, that is equal to 0.40 meter, we know from the previous part. So this distance is half of that. You can see that this distance is half from here to here, this distance is half of that, lambda by 2. So this length, because we know that this length is half lambda, 1 over 2 for first harmonic. So this L is equal to lambda over 2. So lambda is 0.40 divided by 2, we get 0.20 meter. So this is the length. Okay, okay, for the part C, if the string had two fixed ends with the 0.70 meter long, why would be no stationary wave to be formed? So stationary wave could not be formed in this situation. Why? Question asks. So wavelength of the string may be greater than the 0.70. Okay, so if the wavelength is greater than 0.70, so it is possible that the stationary wave can be formed. Okay, so this option is not correct, this option is wrong, this option is wrong, because if the wavelength is greater, if length is 0.70, so wavelength must be equal to, we know that lambda is equal to question mark. So if L is equal to lambda over 2, so lambda is equal to 2L. So lambda is equal to 2 into 0.70 meter. So lambda is 1.4 meter. So if this option prevails, so there might be the stationary wave. Okay, so this option is 0, because in this case we have no stationary wave. If the string was 0.70 meter long, then both ends would be antinode. No, which is not possible if the both ends are fixed. Okay, so if the string was 0.70 meter long, so then the both ends would be antinode. the there is possibility that the both end be antinode. Okay, so no, this option is also not correct one, because both end can't be node, because if the string is fixed end, so we have the end nodes, and the string length must be 0.70. Okay, this option is not the correct. Okay, now the last part, last one, C option is the correct one. Both end can't be node, as the, because we know that at the end we have the nodes. When the string is fixed, we have the two nodes, and this node internodal distance 0.20 meter, 0.20. But in this case, our internodal distance is, we know that the wavelength is 1.4 for the string of length is 1.4. The wavelength is 1.4 meter. For the length of 0.70 meter, the wavelength must be equal to 1.4. If the wavelength is 1.4, mean this distance is 1.4, is this is 1.4. So what must be the this wavelength? This is the internodal distance must be equal to, internodal distance must be equal to half of that, mean 1.4 divided by 2. Node to node distance must be half of that, that is 0.70 meter. So it can't be the distance 0.20 meter, so it's 0.70 meter. So that's why the no stationary standing wave can be formed, because our internodal distance in the previous part we see that that is 0.20. So if length is 0.70, so our internodal distance should be 0.70. So it is not possible. So no stationary standing wave can be produced in this way. So this option C is the correct one. Okay, thank you.